Question 5. So once you fit data, you actually want to see if there are any probable outliers in your data. By outliers, I meant cases that do not behave as expected by the model. Therefore, the concept of outliers could be somewhat relative because some outliers may not be outliers anymore if you change your model. Outliers matters because those outliers might make your parameter estimates biased. So you should make sure your data does not have any outliers. Or if any, you may need to decide to include it or exclude it. There are couple of ways to detect the outliers, box plot, and residual statistics and influencer, and then identify the influencer cases using the Cook's distance. So simply the box plot, we are not gonna draw this using SPSS, but you may remember that when we draw the box plot like this, there was some kind of point. Remember that? Right? So some box plot has longer tail and then something like that. Those dots indicated the outliers. And then the residual statistics. You doctorally cover this in the class in the lecture, and then standardized residual. Once you feed your data, and then there is a expected value y, and then observed value y. So when you fit your model has some linear functions y equal a plus bx or something like that. And then when you plug in x, and then you already got the coefficients and the intercept, and then it would give you some corresponded y, right? And then we call this expected y. And then observed y is the actual y that we have in our data set. And then these two might have some differences, right? Because our model is not perfect, so always it would have some discrepancy between these two. And then what do you call this? We call this error. Or another name is residual. So standardized residual. The residual has some kind of distribution, so we standardize this, make it set to the mean to be 0, and then the unit gonna be the standard deviation gonna be 1, right? So we standardize the residual, and then the residual value, the 90 per if the 95% of standardized residuals is between -2 to +2, then it will not have the problems. However, if you have more than 90 mm, more than 5% out of this range, -2 to +2, then you would say there is some outliers out of this, and these outliers actually make some bias in your findings. Then you may need to determine how to handle these cases, which would have too large or too small standardized residuals. You could kind of like exclude them or like change your model to reduce these standardized residuals. And then the other way is a Cook's distance. So we actually gonna check the Cook's distance using SPSS, and then Cook's distance is actually the case if the Cook's distance is larger than 1, that means the cases will have um, critical influence in your parameter estimate. That means this is the kind of like the indicator of excluding those variable because not excluding those cases because those cases are actually very influential on your findings. So how do we detect that? Go to um, SPSS and then go to analyze and regressions and linear regressions. All things are same, and go to save. Go to save. So over here, if you want to save the residual. You can click on standardized residual and standardized residual. You can click those menus, then you could get the standardized residual, and then you could see the range of standardized residual to determine any probable outliers. So, but we're gonna check the Cook's distance. So under the distance menu, there is a Cook's distance. Click that and click to continue, and then yeah, let's see. So we saw this, right? And we saw that. And there is a one more table that we haven't seen before in residual statistics. So over here, where is the Cook's the second from the bottom. So over here we have the minimum value of Cook's D as 0 up to 1.969, right? This is the Cooksey's the range of Cooksey. And then according to the criteria that we learned in the class, the lectures, the larger than 1, sorry, if the Cooksey is larger than 1, maybe just large not equal to larger than 1, this might have probable bias. So you can kind of go back to the cases and then which cases has a larger than 1 for Cook's D and then check those cases. For instance, case 1 and then case 2. These two, for instance, if these have 1.2, 1.96, something like that, and then you can kind of have to look at these cases individually and then to see what would happen or how you could handle this. For instance, if those two cases are not kind of like the sample that you intended to collect, some for instance out of the age range or bound or they are like they have too many missing values, something like that. That means those are not quite valid cases for your analysis, then you may need to exclude them in your analysis. Or if they are just fine, that means you may need to um, revise or at least consider to revise your model, including some other variables or excluding some variables, something like that. So in this data, the maximum value of Cook's distance is according to our table 1.969. Um, so there is no outliers in this data because the Cook's D, I'm sorry, there is a couple of outliers in this data because you may need to check how many cases have the Cook's D, and then you could say because um, for instance, like 2 or like 3, whatever numbers of the outliers in your data, because blah 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 data, blah 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 cases have Cook's D larger than 1. You can say like that if there's the maximum value of Cook's D is less than 4 or less than 1. What does that mean? That means our data does not have any outliers um, because the maximum values of Cook's D